Hello everyone. Today we are here to present our presentation on the topic of design and simulate a wind turbine power system for telecommunication tower. Myself Krunalsinh Chauhan and my group partners are Bhimani and Patel Akshitabahen. Let's start with the outline. Outline consists of introduction, literature review, wind turbine power system for cellular tower, wind turbine steady-state modeling, as well as analysis using Homer, wind turbine system dynamic modeling and analysis using MATLAB, result, and finally conclusion. Introduction. We all know that nowadays energy demand is increasing day by day and maximum energy production is done by fossil fuel, coal and natural gas, which causes various environmental issues. There are various forms of energy, renewable energy available with immense potential. As of now, around 23,900 tetrawatt-hour total power generation we use, in which around 5.3% wind energy we use to produce electricity. We can see here in the graph the 36.7% is produced mainly from the coal and lowest from the other resources like biomass and all 2.5%. If we talk about wind, it's stand at 5.3%. Literature review. Renewable energy based power generating system have some benefits over typical non-renewable power generation. Wind energy is a kind of solar energy. Wind energy describes the process by which wind is used to produce electricity. The wind turbines convert the kinetic energy present in the wind to mechanical power. Wind energy is a renewable source of energy that determines the total power in the wind. The wind turbines which convert kinetic energy to mechanical power, whereas the mechanical power is converted into electricity which acts as a useful source. Power of wind is given by the half rho a v cube, where rho is the air density, a means stripped area of blades which is given by pi r square, and r is the radius of blades, and v is the velocity of wind. Mechanical power is given by the second formula. Further, there are two types of wind turbines mainly, horizontal axis wind turbine and vertical axis wind turbine. This table represents the few main differences between them. Position of the blades toward the wind is parallel in the horizontal axis wind turbine, while the position of the blades toward the wind is perpendicular in vertical axis. Maintenance is quite difficult in horizontal axis wind turbine, while easy in the vertical axis wind turbine. Power consumption and efficiency are more in a horizontal wind axis turbine, and vertical axis wind turbine have a less power consumption as well as efficiency. Operating conditions for the horizontal axis wind turbine are medium wind conditions, and for the vertical it's low wind conditions.
Wind turbine power system for cellular tower. As my friends explained what is wind energy, now we can discuss about how we use wind energy for the cellular tower. We use Homo software to design a steady-state model of cellular tower wind power system. For a case study, we take Gujarat, India, where 3 BTS house one cellular tower required 2.52 kilowatt electrical power. To fulfillment of this requirement, we use wind turbine named AWS HC 1.8 kW with the battery capacity 1.536 kilowatt hour. For battery backup, we need 36 unit of battery. The average load of this whole system is 60 kilowatt hour per day, and the peak load is 559 kilowatt hour. In this figure, we can show the whole system for the wind power system, which is used to power the cellular tower. After doing number of simulation in Homer, we can get this result. Uh, Annual energy production of the wind turbine is 31,000 kilowatt hour per year with the excess electricity of 31% per year. This whole system is only reliable on the wind turbine, so that's why here renewable fraction is 100%. We can see from this graph there is a output from the different month is different. Now talk about the cost analysis which we get from the Homer optimization result. The total NPC is $1,66,176. as the capital cost of the wind turbine and battery is quite high. So here NPC is quite high. The levelized cost is 0.6504. It's quite normal compared to the other type of system. And operate if we talk about the operating cost, then it's only $2,606 per year. That is quite nominal compared to the other system. Now, factor affecting on the wind power system. There are various factors which we have to consider while designing of a wind power system. First is the site selection. For a wind turbine, turbulence is a major issue. Turbulence can reduce the output power up to 15 to 25%. That's why we have to consider any tree, house, and building during the designing of the system. Second is the availability of the wind resources. As we all know, wind is unpredictable resources and output of the turbine is directly proportional to the cube of the average wind speed. So there is a slight increase in average wind speed, we can get maximum output. So this is the most important factor which we have to be considered. Next is the wind turbine performance analysis. To do this performance analysis, we have to take a record of the wind velocity for a year on hourly basis. On that basis, we can calculate the average performance of the wind turbine. And last is the wind turbine cost analysis. After the sizing of the system, the cost is the second most crucial aspect we have to consider during the designing of the wind power system. Wind power system require a very less maintenance cost because it does not require any manpower or fuel to operate. That's why it is a most inexpensive system compared to the other power plant. Wind turbine power system dynamic modeling. The output power from the wind turbine is given by 1 half rho A Cp V cube, where Cp is the maximum power coefficient and it is depend on the lambda, tip speed ratio and theta pitch angle. To get a proper and desired output, we have to control these two parameters. In this figure, we can see that pitch angle control and rotor speed control. Rotor speed control is directly connected to the permanent magnet generator to control the tip speed ratio, and pitch angle control is connected with the wind turbine, so we can get a proper and desired output for the cellular tower.
System modeling in MATLAB. From the simulated circuit, we can see that a mechanical torque is produced by wind turbine at certain pitch angle and certain wind speed. This mechanical torque later converted to the electrical supply by induction generator. Generally, the telecommunication load is worked on stable DC supply. So we need a stable DC supply. After that, this electrical power which is produced by induction generator converted to the DC supply with the use of rectifier. But rectifier produced unstable DC supply, so we need a stable DC supply. So we linked a DC to DC converter to the circuit, and this converter supply the load. But sometimes there is extra power which is not required. So this power is basically stored in battery. Let's move to the output extracted from MATLAB simulated circuit. In this particular slide, there is two different graphs. The left one is the output power of the load and the right graph represent the load current which is supplied to the load. From the output power we can say that the power is almost constant in range of 1500 to 2000 kilowatt, while in the same time load is also constant around 40 to 50 ampere. Control system of dynamic modeling. Before we move to the control part of the system, there is one question: why control system is needed? There are mainly 5 objectives for that. First, to maximize the power productivity of wind turbine. Second, maximize the wind harvested power in partial load zones. Third, ensure a specific level of reliability of mechanical parts by reducing fluctuating loads. Fourth, fulfill stringent power quality requirements such as power factor, harmonic, flickers, and etc. And fifth, to produce electrical power throughout a variety of wind velocities. Control system of wind turbine. To control wind turbine, control system has mainly 3 subsystems: aerodynamic control, variable speed control, and grid control. Before moving to the control system, as we know, there are 3 different types of wind turbines: small wind turbine, medium wind turbine, and large wind turbine. In this particular part, we will focus on small wind turbine. For small wind turbine, load side control method is generally used. For small wind turbine, no wind speed and RPM sensor are needed, and no supervisory control is also used, just because it is not economical. Yaw angle is also controlled by turbine tail vane, and it has passive pitch control. For control of power in wind power system, mainly done in 2 different categories, such as above rated speed control or falling mechanism, and second, below rated speed control. Above rated speed control. For 1.8 kilowatt AWS HC wind turbine, power is controlled by falling mechanism for speed above rated speed. Furling is the technique of moving the blades of wind turbine out of the direction of the wind, either manually or automatically. In order to stop the blades from turning, below figure represent how the furling mechanism is described in simplified manner. The useful wind directed to the plane of rotation is the effective wind speed V in normal situation. The thrust is the force acting perpendicular to the rotational plane. When the wind speed picks up, both the thrust and P force on the turbine rise. Furling minimizes the produced drag from the rotor's lift as well as cross section. By lowering the angle of attack, aerodynamic power is likewise reduced. Below rated speed control. If wind speed is below rated speed, then power is controlled by converter and PI controller. Wind speeds are not very high. The rotor may cease to operate as aerofoil and come to a slow spin. The figure depicts the simulation circuit with PI controller, which is used to control wind power when wind speed is below rated. When PI control is implemented to control wind power system, then get proper output power to telecommunication tower irrespective with any error in the system.
Protection of system. The protection system include mainly mechanical and electrical protection. In small wind turbine, manufacturers typically provide some inbuilt protection in their turbine designs. Let's talk about free protection or speed protection, which is up tilt trail, which is assisted by a hydraulic mechanism. Second is electrodynamic switch for shutdown in case of malfunction. And third and final is MCB for the overcurrent protection. Maintenance of the system. For reliable and uninterrupted function of power system, regular maintenances are necessary, and to ensure that the wind turbine is running at its best capacity as well as efficiency. There are mainly two types of maintenance as per the time: biweekly test and annual test. If we talk about the biweekly test, it consists of inspection of the battery bank, brake test, as well as inspection of tower and its mechanical structure. Now let's see annual test. It consists of battery equalizing test, blade and generator, as well as brushes and brush holders test. Result: from above case study, it is crystal clear that designed wind turbine power system is appropriate to provide required power for the 3 BTS housed telecommunication tower in Gujarat, India. It is economically feasible as total NPC is 166,176 and levelized COE is only 0.6504 and operating cost is 2,606, which is less compared to diesel operated cell tower. Conclusion: currently, as of now, telecommunication tower mainly uses diesel as a fuel for obtaining power to run, but there are few alternatives like wind power and solar power. So proposed wind turbine power system for powering telecommunication tower is one of the best available options at many locations, especially in the windy locations. So we can easily harvest the electrical power from the available wind power. This way we can achieve the self-sufficiency in terms of energy consumptions for telecommunication tower through the wind turbines. Finally, thank you so much for your interest and attention.